If we don't have phosphorus, we don't have food. And the phosphorus resources are running out.
Earth. More than 8 billion of us call it home. And we add 1 billion more every 12 to 15 years. Our population has become so large that the Earth is struggling to keep up. Modern agriculture is working hard to ensure global crop production while also trying to minimize the environmental impact of agricultural practices and the cost associated with them. One part of the solution is helping plants increase their nutrient use efficiency. Scientists have identified 16 essential nutrients that plants need. But researchers at Michigan State, like Hatem Roashed, are focused on one:
Phosphorus. Phosphorus is an essential macronutrient required for plant growth and development. If we don't have phosphorus, we don't have food. So my research focuses in studying how plants sense and respond to nutrient deficiency.
When nutrients aren't present in the soil, farmers supplement them with fertilizer. But using phosphorus-filled fertilizer is only a temporary solution. There are 3 main problems. 1, it pollutes.
Since the first Green Revolution, our approach is to over-fertilize. What was the solution of yesterday is become problem of today. We know that the plants are taking 30 to 40% of the phosphate fertilizer that we are putting in soil.
The remaining 60 to 70% gets into our waterways. This can lead to ecological problems like fish kills and harmful algae blooms that we see annually in Lake Erie.
We are spending money to clean up all this water. This is environmental degradation and need to be addressed.
Another issue with relying on phosphorus is scarcity. Over 80% of the world's phosphate rock reserves are located in 5 countries: Morocco, China, Egypt, Tunisia, and Russia. Since 2020, the pandemic, geopolitical disputes, trade wars, and escalating fuel prices have driven an over 400% increase in phosphorus commodity prices. Lastly, phosphorus is not sustainable.
Phosphorus is a natural non-renewable material, and experts agree in saying that we are running out of worldwide phosphorus reserve in a few decades from now. And this is what we call phosphorus peak.
If we continue at our current levels, that peak, where global phosphorus requirements will overtake global phosphorus supply, will occur around 2040.
So if we don't act, all the production worldwide will drop. The quality of our crop production will also drop, and likely we will face a serious food security issue.
Working with his team in the labs at Michigan State University, Dr. Roashed is giving plants a leg up or a root down on their growth cycle.
The only way that we can do is to empower plant and increase the plant resilience capacity and help plant to grow and complete their life cycle with the minimum of phosphorus in soil.
The plant cycle works like this. Once a seed is planted, it sets down roots to pull those necessary nutrients from the soil. If a plant doesn't detect the phosphorus, it stops growing roots.
We have identified the key gene that regulates root growth in response to phosphorus deficiency. This gene is Arabidopsis root-specific kinase, RSK1. And by overexpressing this gene in plant, the plant root continues to grow despite the absence of phosphate from soil.
The more growth, the more opportunity to find necessary phosphorus in the soil.
By gaining new insight on how this gene is regulated, we can also manipulate the crops in a way that they are more resilient to phosphorus deficiency.
Reducing our dependence on phosphorus fertilizer, lowering costs for farmers, limiting the amount of phosphorus that reaches our waterways, and ultimately helping to feed more people.
Michigan State University is a worldwide leader in agriculture science. This is bringing a huge hope to solve the world phosphorus crisis.